Hello. How are you guys doing? I'm going to make a little lecture, a little presentation in the immune system for my students in phlebotomy, for my nurses, also students in which I teach immunology and infectology. This is just a mini lecture on the immune system. I hope you like it, and I hope you really love it the way I do. See ya! All right. Now that these days we are facing respiratory viruses such as the flu, the RSV, the COVID-19. Do we have anything that can protect us in not getting admitted into ICU, into the ER, without we needing to go through the vaccine, which are very good, which are more safe and effective than 50 years ago? But can we do something to make us strong? Yes. We have what is known as the immune system. Now, the immune system is also known as the lymphatic system. And when we talk about the immune system, we are talking about two different aspects of them. The innate immune system, which I'm going to talk separately, but I want you to see that the innate immune system is part of what we know in the white blood cells types monocytes, which include the macrophages or dendritic cells. But when we talk about the macrophages, they are the ones that identify viruses, microorganisms, and they go there and they phagocyte. Phagocytes means to kill, to engulf, to swallow. So that's part of your immune system. That's part of your defense system. And we also have the adaptive immune system. The adaptive immune system, which is also the home of the natural killer cells, which in combination with the macrophages will specifically kill, defend, engulf, destroy anyone that is coming to attack us from a virus point of view or a microorganism that is not supposed to be in our body system point of view. In another word, we have two strong systems, and that we call it the immune system, the innate immune system and the adaptive immune system. Okay, guys, this is very simple. Your immune system, as I said before, we could divide that into two aspects, the innate immune system and the adaptive immune system, where we're going to talk about the innate immune system. Innate immune system is what you are born with, you and I, in which, just to talk about, we have, as you know, in hematology, in immunology, in bacteriology, we have the white blood cells. We have the lymphocytes, we have the monocytes, neutrophil, eosinophil, basophil. So that is part of your defense system mechanism. As you are born, that innate system is very strong because it not only has the B cells. Let me write it down so that you can see it here. You don't only have the B cells. B cells come from bone marrow, and you also have the T cells from the thymus gland. I know my handwriting you're gonna go crazy with. Trust me, I am too. So anyway, so the innate system is what you are born with. And just to make it specifically, you have the B cells and you have the T cells. They produce a lot of substances, antibodies, globulin, immunoglobulins, proteins that will defend your body against any invader. It happens to be that you and I, we have, let's say, 100 trillion cells. Like if we talk about your liver, your hepatocyte cells. Your hepatocyte cells has a specific ID number, or let's call it plate number, like a car, right? Your brain cells, your muscle cells, everything within your body has a specific plate number. Let's call it, for example, 1, 2, 3, 4, and 5. It's just an example. So when anything that comes into your body comes with a different plate number, your innate immune system, your monocyte, your macrophages will detect, will evaluate, hey, this car is not supposed to be here. Look at that plate number. That doesn't belong here. And they will start and they will attack specifically these microorganisms by swallowing, by phagocytosis, which means to engulf, to kill. And that's your body protecting yourself. Besides that, the monocytes produce something that is known as interferon. Interferon, many types. But as the name suggests, that interfere with virus replication or multiplication. That's so powerful that we even use that now in the hospital, in a specific plasma, in a specific medications. Very strong. But as you get older, your immune system becomes very weak. And when it becomes very weak, you don't react that easily, that fast enough to stop replication. But guess what? Besides that, you have something else. You have the adaptive immune system. And that adaptive immune system is so as I was saying, that adaptive immune system, remember once again, if we get infected, let's say by the flu, let's say by we have right now the COVID-19. We also have right now the RSV, rhinal syncytial viruses. So if we are attacked by any of these three viruses and we don't have vaccine, which by the way, the vaccines we have today are completely different in being effective and being safe than 50 years ago. So if you get infected by a natural means, meaning like you just got the cold, your body will create a specific antibodies produced by these guys here, the B cells, the bone marrow cells. This plasma B cell will produce antibodies specifically to whatever is invading you. Because remember, we have a specific plate number. When something comes to invade us with a different plate number, we identify that as a foreign particle that is not supposed to be there. And automatically, your T cells has many subdivisions, and they will go and attack and kill those invaders. And at the same time, it will produce once again a specific antibody for that specific virus. So let's say you have the flu, it will create a specific antibody for that flu. You have the SARS-CoV-2, it will create a specific antibody to that SARS-CoV-2, just for you to get an idea. So all this adaptive immune system, which is very, very strong, it will get strong as we get older, as we are exposed to vaccines, as we're exposed to specifically infections. Now, what can you and I do to keep these guys very strong? Vitamins, minerals, exercise, proper nutrition. You stop specifically that fructose molecules, which is the bad player. Not glucose, fructose. Like the table sugar you have, the table sugar that you and I use is made up of two things, of glucose and fructose. Now, glucose is not a problem. It's not that sweet either. Fructose is the bad guy. This fructose is the bad guy. And that fructose inactivate killer cells, plasma cells, your immune system. It takes down your energy to produce all this type of mechanism to defend your body. So every time you're eating something that is very sweet, just remember that that will make your immune system very weak. All right, guys? Now, when we talk about hematology, we are talking two things within the blood. Hema means blood, logy means a study of. So let me just put everything in big. That way we could talk more easily. Okay, so imagine a powder juice, a strawberry, for example, and then you get a cup of water. Okay, and then you pour that powder, a strawberry, and then you put water into it, and then you start mixing it. What's going to happen is that the water is going to start changing color, like red, right? And then you will see later on that the whole powder portion will settle down at the bottom, right? Well, if you look at those two divisions, that sedimentation are the red blood cells, the white blood cells, and the platelets. And the whole liquid part, that will be the plasma. So in hematology, we have that the blood is divided in two portions, the liquid portion and the cellular component. Normally, you will see that when we want to study the complete blood count or a CAM7, a lipid profile. So from blood, we could study many things. Now, because we are talking about the immune system, look at the forms elements. And we have that the white blood cells are subdivided into neutrophils, lymphocytes, monocytes, eosinophils, and basophils. With the lavender top tube, we could study the forms element. Now with a gold top tube, we could study the plasma. And why do I want to study the plasma? Well, it happens to be that in the plasma, we have 90% of water. Besides, you have solutes. The word solutes means particles that dissolve in water. And we also have what? Proteins. Proteins such as what? Globulins, gamma globulins. Yes. And we're going to talk about those globulins, those proteins. Even though that the majority of the proteins in our blood plasma or blood stream circulation, the majority of that is albumin. Now, there is a process known as electrophoresis. Electro from electricity and phoresis means to separate. So proteins, normally by means of electrophoresis, we could separate and we could count all of them. That's a simple, normal test that we do known as electrophoresis to separate, in this case, proteins. And we're going to talk about proteins. You'll see right now. All right, so when we do an electrophoresis study, they will present it like this. If you see here that we have the albumins, which account for 60% of everything that we see in the bloodstream or in the plasma, and which main function, if you see here which says common, is to maintain the pressure, the osmotics, the movement of fluid. All right? Why? Because wherever we have proteins, it will pull off fluid. So that's what the albumin normally do. It control the colloid. Colloid means protein, osmotic pressure. It controls the pressure how these proteins are moving back and forth. Besides that, we have the alpha 1 and alpha 2. We also have the beta, and then we have the globulins. The word globulins means protein. Once again, all of this is about proteins. Now, if I'm talking about proteins, in this case, globulins or gamma globulins. Why? Because that's when we have the immunoglobulin A, G, E, G, and M. From all of them, the one that we have the least of are the immunoglobulin E, which normally they will multiply in the presence of something that will cause any allergic reaction to you or to me. Besides that, the vast majority of the immunoglobulins is the G, as you can see here, 10. And what does act upon? It reacts upon viruses and bacteria. So anytime that we expect or that we suspect that we have a bacteria or a viruses, if we look into the globulins, the gamma globulins, I'm going to look for the IgG. If I see an increase in the immunogamma globulins, it's because of the presence of any virus or bacteria. So the immunoglobulins, once again, are also known as antibody. So when you talk about antibodies, you're talking about immunoglobulin. When you talk about immunoglobulins or globulins, you're talking about antibodies. They mean the same thing. And they are there to protect you and me against any invader that is not supposed to be in our body, organ tissue, or in our blood. Now that we are with this triple epidemic, the flu, the RSV, the COVID-19, just to use as an example, the COVID-19 vaccine, remember, antibodies, immunoglobulins, gamma globulins, like B lymphocytes. So what does the B lymphocytes will do? They will produce antibodies. These antibodies will inactivate any foreign agent or viruses. They will go there and fight them and phagocyze them. But normally, as I said, when we produce our antibodies, is within 42 days after you've been exposed to either a vaccine, to either a virus, to either a bacteria, that you will have the immunoglobulin G that will there positive to have an immune robust response to that invader. So if that invader comes back again, you already have memory in how to fight it and how to kill it. So normally your antibodies will shift from time to time if you've been exposed or you've not been exposed. In the period of incubation, the very first one that may up is the IgM. After that IgM, which is the number one that's going to react to it, we're going to have the immunoglobulin G. So if we are looking for any marker of a virus invasion to our body, we want to look for the IgM. IgM means acute, recent exposure, and IgG, it means that it's already been there for more than 7 days. But your body and I will produce the IgG, and that will protect you, and that has the memory in how to phagocyte, to kill, to defend that virus, that invader into your system and my system. All right, guys, thank you very much. This is with a lot of love for my daughter, Kaylee, and I hope all of you, all my students, all my nursing friends, nursing students, all my medical students enjoy what I have. If you want any other lecture or any other mini introduction to anything, just write me up and I will be there for you, all based on scientific evidence. The glory to God, the creator, the one that did that immune system, the best you could ever had. Take care.